Alright, welcome to this lesson with Teacher Kamanga. In today's lesson in physics, we're going to look at moment. Therefore, the questions which will help us in understanding this topic, moment, we are going to look at a question which has been extracted from the 2019 GCE Science Paper 1 on section B, question number 2. Okay, so in this case, we have this question which states figure B2.1 is a uniform plank length 100 centimeter kept in equilibrium by a 3 kg and 1 kg mass placed 10 centimeters and 20 centimeters from each end respectively. Okay, so what we need to understand in this lesson is that we need to understand what moment is. So moment can be defined in two ways. So the first definition that I'm going to make known to you is the numerical definition. So the numerical definition of moment about a pivot is defined as the product of the force and the perpendicular distance of its line of action from the pivot. Okay, so I hope you get that one. A moment is defined as the product of the force and the perpendicular distance of its line of action from the pivot. Okay, so if we hear it correctly, we are saying it's a product of the force and the perpendicular distance. So we understand a product is a number that we get after multiplying two numbers. So for instance, if we say moment is equals to the product of force and the perpendicular distance. See, so we have the force times the perpendicular distance. The number that we're going to get is the one that we're going to call moment. So moment, since the force is in newtons and the distance is in meters, so the SI units for moment is Newton meter. So you understand some questions are going to bring SI units, maybe distance, they put centimeters. The first thing that you're supposed to do, you change those centimeters into the meters so that they can fit on your formula like that. All right, so we need to understand that. So I'll just give you a quick example on how this one can be demonstrated. So for instance, we have this metal rod. Okay, so we are calling this point as the pivot. Okay, pivot. Then we have the distance from here up to there, okay, which we're calling the distance. Then if for instance the force has been applied in that direction, okay, so we understand this distance and the force, they are not perpendicular to each other. Therefore moment cannot be produced in this case because of the force that has been applied horizontally to the distance. But rather, if we change on how the force has been applied, for instance, if the force has been applied in this direction, meaning that this object will be able to move in this direction about this pivot. Therefore, moment is going to be produced. In this case, we just multiply the force that you are applying here times the distance. The answer that you're going to get, that will be the moment. Okay, now to answer our question in today's lesson, we are going to look at the principles of moments. Okay, so the principles of moments are very, very important to understand because that is a demonstration that we are seeing there. So the principles of moment states that for a body to be in equilibrium, when we say equilibrium, we mean for a body to balance, the sum of clockwise moments about a point is equal to the sum of the anti-clockwise moments about the same point. So for instance, we have this here. This one is the one that we are calling the pivot in this case. So from the pivot, we have two moments that we can relate from here, from this direction, okay, and also from that direction. So there are two points that we are going to look at. So that's why we need to apply the principles of moment in this case, because we are seeing moment can be produced in two directions. So we have one and also two. This is very, very important to understand. All right, now let's come to our question of the day. So the question is saying, calculate the moment of the 3 kg mass. Calculate the moment of the 3 kg mass. So we've been given the 3 kg mass. Our pivot is this one. So we are just looking at the moment that is going to be produced after the force has been produced, has been applied at the 3 kg mass. Okay. So now what we need to understand, since we have said the moment is force times distance. Okay. Okay, force times distance. Therefore, here we just need a force where there is a mass, and we understand force can be easily calculated to say force is equal to mass times acceleration. This acceleration due to gravity, it is always known, it is 10 newtons per kg. Okay, 10 newtons per kg. So we need to understand like that. All right, so what we are going to do for us to have the force there, we just multiply 3 times 10. Okay, we're going to have 30. Okay, so this 30 is the one that we're going to use in our equation because it will be now 30 newtons, which is the force that we need. All right, now when you look at the distance there, it is 20 centimeters. So 20 centimeters, our distance must be in meters. Therefore, for us to change that 20 centimeter into meters, we just divide 20 divided by 100. Okay, so what we're going to have are the meters. Okay, like that. Where am I going? I'm getting the 100. We're looking at the conversion units where we're saying 1 meter is equivalent to 100 centimeters. So if we say x is equivalent to x meters is equivalent to 20 centimeter, when you do the arithmetics, you're going to arrive at this point where I'm trying to multiply. All right. Okay, so what we're going to do in this case now is we are going to say, since we have already, so we say 20 divided by 100, you're going to have 0.2. Okay, so the 0.2 and the 30 are the ones that we're going to multiply. So to have our answer, we're going to say, so since now we have the force, which we found that is 30, we've found that it's 30 newtons. Okay, the distance we've already do the calculation, which is 0.2 meters. All right, so we come to our formula where we're saying moment is equals to force times distance. So we're saying 30 times 0.2. So 30 times 0.2, you're going to find that you're going to have 6 Newton meter. Okay, so the 6 Newton meter, that is going to be our moment that is going to be produced by the 3 kg. All right, so I hope you've gotten it how you're supposed to calculate. Okay, now let's come to the second one. Okay, so we found that it's 6 Newton meter. Okay, I indicate it here. Okay, let's come to the second one. I'm saying find the weight of the plank. Find the weight of the plank. Now, to find the weight of the plank, we need to understand one thing. We need to understand what is the center of mass. So the center of mass, it is a point on an object where all the masses seem to concentrate. So since this plank is 100 centimeters, so the point at which all the masses seem to concentrate is at 50 Mach. Okay, so we need to understand that is at 50 Mach. Now, how are we going to find the 50 Mach on our plank there? So if you see, we have 10 centimeters there. We also have 20 centimeters, then we have 50. Meaning when you add the 10, 20, and 50, it will give you 8. Now, what we need is to find where the 50 Mach is. So what we need to understand is that since we already have 30 this side, then from the pivot there to somewhere here, this is where we're going to have our 50. Okay, from the pivot to somewhere here, this is where we're going to have our 50. Then on the other end there, we're going to have the 30 that is going to remain. So meaning that the from where the pivot is to where the center of mass is, we have somewhere 20 centimeters. Why are we saying 20 centimeters? Because when we add the 10 centimeter there, this first 10 centimeter, the 20 centimeter plus the other 20 centimeter to reach at 50 here, it will give us 50 centimeters. So we assume that this is where now our center of mass is going to be, because that is the midwest point. So we are going to calculate this weight based on the principles of moment, because this is where we're going to find our weight. Okay, so let me just indicate it so that you should be able to be seen clearly. So this is where our weight must be calculated. All right, so I've indicated W to indicate weight. Okay, so we're able to see this side we have two moments that can be produced. The first moment is the weight that can be produced by this the moment that can be produced by this weight that we need to calculate. The second one is the moment that can be produced by this 1 kg mass. All right, then on the other side here we only have one moment which can be produced by the 3 kg mass that we've already calculated, which is the 6. Okay, so for us to find this weight of the plank, what we need to do, it is just to find the value of the W. So how do we find the W? Remember on my preamble I said the principles of moment states that for a body to be at equilibrium, or for a body to balance, the sum of clockwise moments at any point is equal to the sum of the anti-clockwise moment at the same point. So the moment here that we've calculated must be equal to the moment that is going to be produced on the other end, regardless of how many are they. Okay, so we need to understand to say all the moments on the other side, we can add them and we equivalent them to the moment on the other side, which is the clockwise moment. Okay, so let's try to start our calculations based on that one. Okay, this point must be well known because it's a reference point. All right, so what we're going to say, since we are saying we are following the principles of moment, so we'll say F1 times D1, okay, is equals to, so F1 times D1, we mean the force here, 1 times the distance 1, that is the 20 there. So is equals to F2, force 2. This, our force 2, is the one that we want to calculate, which is the weight. So we've used just the force 2 times the D2. So the distance number 2, it is the distance from the pivot to where the weight is going to be, which we have said it is 20, because that's where the 50 is going to, where the 50 mark is going to be. So we have 20 centimeters there, okay? Then again, this must be added to the other moment that is going to be found on the other side, which is F3, force number 3 times distance 3, okay? The distance 3, it is the distance from the pivot to where the 1 kg is, okay? So when you do your calculations nicely, you're going to realize that this side we've already calculated, which is the 6 newtons, okay, is equals to F2. This F2, we're going to leave it like that because we want to find the answer here, okay, times the distance 2. The distance 2, I've said the distance from where the weight is to the pivot, it is 20 centimeters. So like what we have done to the 20 centimeters on the other side, also it must be able to be changed. When it has been changed, we're going to have the 0.2, okay, like what we did on the first. So you can still use the first example that I did for you to be able to arrive at the 0.2, okay? So this one must be added to the force number 2. Force number 3, sorry, the force number 3, it is the one that is going to be produced by the 1 kg. So for us to find the force here, we just multiply by 10. The 10, it is the gravity, okay, just like what I did to the 3 there to calculate the force that we have had, which is the 30, okay? So you do the same. So here the force is going to be 10, okay, 10 newtons times the distance here, the distance from the pivot there to where the 1 gram is, it is 50. So the 50, you also need to change it into meters. So 50 divided by 100, you have 0.5, okay? You have 0.5 that side. All right, so we need to understand when it reaches at this point, all the figures that we're talking about, they must be able to be known, okay? So we have the 0.5 this side. So in short, what we are saying is that we are saying F times 0.2 plus 10 times 0.5, okay? So what we're going to have, as usual here, of the 6 Newton meter, okay, is equals to, okay, so we have F2 0.2, all right, plus, so 10 times 0.5, you have 5, like that. So the 5 comes on the other side of the equal sign, to the other side of the equal sign, like that, okay? So the 5 has come to the, from this side to this side. So we're saying 6 minus 5 newton meter is equals to F2 0.2. All right, so here when we subtract, we're going to have 1 Newton meter, okay? 1 Newton meter is equals to F2 0.2. So this side we divide by 0.2, even this side we divide by 0.2, okay? So what we're going to have, this side, 1 divided by 0.2, it is 5, okay? Then is equals to F there, F2. So meaning that our answer to the weight that we are supposed to calculate here, the weight of the plank, the answer is going to be 5 newtons, okay? 5 newtons. This is how we're supposed to calculate our answer. So you just follow the arithmetics nicely so that you're able to see how I've arrived at this answer. It's very, very important that we are able to know. All right, okay, so let's come to the next question. The next question is saying state one application of the above setup. State one application of the above setup, okay? So the above setup that we are seeing, so here we found 5 newtons, okay? So the above setup that we are seeing here, where we have just applied the principles of moment. So I believe we know what a seesaw is, where another child will sit on the other side and also another one will sit on the other side, so that they are able to move up and down, okay? So we have a lot of application of this setup. You can talk about the seesaw, you can talk about the opening and closing of a door, you can talk about the opening and closing of a tap. All those are examples. So we'll just put opening and closing of a door. Opening and closing of a door. So when you are opening a door or closing a door, the point at which the pivot is, it is those inches, because that's where the turning effect is taking place from. So we need to understand. Remember, I said the moment can be defined in two ways. We have the numerical definition, which is given us the formula, and also we have another one which is saying moment is a turning effect of an object. So as the door is turning, that is where the turning effect will be taking place from the inches. So opening and closing of a door is an example of the application of the setup that we are seeing here in the diagram. Also, when we're talking about a seesaw where another person sits this side and another one sits side, also we are looking at that as also one of the application. Okay, so this has been Teacher Kamanga with you. I hope you go through nicely so that you're able to prepare for your exams. Thank you. Have a good day.